Hey, welcome to the Waves and Sound Review game. Let's get started. Here's 3 questions right off the bat. What is the amplitude, the wavelength, and how many waves are pictured? The amplitude is 6 centimeters. Remember, it's the distance from the equilibrium position, this line here, to the top of the wave, or the equilibrium position to the bottom of the wave. Right? That's your amplitude. The waves, we start here. You have to have a crest, a trough. That's 1 wave, and this would be another half, so 1.5 waves. And the whole wavelength is the distance from the crest all the way down to the trough, so 24 centimeters would be your full wavelength. Good job if you got that one correct. Let's move on. Here's questions number 4 and 5. How many nodes and antinodes are there? 5 nodes and 1, 2, 3, 4 antinodes. Remember, these loops here are the antinodes, and where the string meets the equilibrium position are your antinodes. Good work. Tell me a little bit about the electromagnetic waves. Do they move at 300 million meters per second, require a medium to travel through, both of these, or none of these? The previous one is correct if you got 300 million meters per second or 3 times 10 to the 8th meters per second. That's how fast they go. They do not need a medium to travel through. Longitudinal waves need a medium to go through, like your sound waves. So here's question 7. These waves are called square pulse waves. When wave 1 up here is superimposed onto wave 2, which wave are they going to make? Remember, we're talking about some constructive and destructive interference. If you guessed C, that is correct. There is going to be some constructive interference here, which gives you that peak. Which of these waves can be heard? .500 hertz is correct. This is the only one that is in between 20 hertz and 20,000 hertz. Here we have infrasonic, and these two are ultrasonic. How many waves fit along a string vibrating at the second harmonic? So we're talking about waves on a string in the second harmonic. How many waves are on there? Good job if you guessed 1. 1 is the correct answer. Remember, there's 2 antinodes. Each antinode represents a half a wave. Which decibel level is 1,000 times more amplitude than 15? You are correct if you guessed 75 decibels. Remember, every 20 decibel increase is an increase by a factor of 10. So 20 is 10 times more amplitude, 40, 100 times more amplitude, 60 is 1,000 times more amplitude, and we add that 60 to 15 decibels to get 75 decibels.
Wow!
That's right. How many octaves higher is 1600 hertz compared to 100 hertz? Correct if you guessed 4. 4 is the correct answer. Remember, to get to the next octave, you have to double the previous frequency. So from 100, the next octave is 200, 400, 800, and finally 1600 hertz, which is 4 octaves above. For these 2 questions, I want you to tell me how many wavelengths are present on the string, and if the length of the string is 55 centimeters, how long is 1 wavelength? The number of waves present on this string is 5.5 waves. If we start here, we have crust to trough 1, 2, 3, 4, 5 plus 1/2 makes 5.5 waves. Ah, ah, ah. And if the length of the string is 55 centimeters, then you take the length of the string and you divide it by the number of waves. And so the wavelength, distance from here to C, would be 10 centimeters. Good work. Which feature of a sound wave is associated with its volume? That is correct, it is amplitude. The higher the amplitude, the louder the sound. And which material does sound travel the slowest? Very good if you guessed cold air. Cold air is the slowest. Then hot air is the next because they are both gases. Finally, liquid travels faster than any gas. So the fastest one out of these three is water. How many waves fit with a closed air tube vibrating at the third harmonic? You are correct if you guessed 1 1/4, otherwise known as 5 quarters. Remember, closed tubes at each harmonic is every odd quarter. So the first one is 1/4, the second one is 3/4, the third one is 5 quarters. A sound wave moving at 340 meters per second has a frequency of 170 hertz. What is the wave's period? You are correct if you guessed 1 over 170 seconds. Remember, period is equal to 1 over our frequency. If the frequency is 170 hertz, you just put 1 over 170. Good work. Sound travels at 340 meters per second. A hiker yells and hears his echo 3 seconds later. How far is the surface that bounces that sound back? You are correct if you selected 510 meters. Remember, velocity is equal to distance divided by time. Therefore, distance is equal to velocity times time. So we would take 340 times 1.5 seconds. 1.5 seconds because it takes 1.5 seconds for the hiker to yell and the sound to hit the wall. And then another 1.5 seconds for it to reflect off of the wall and get back to the hiker. If you guessed 1,020 meters, then you did not divide the time by 2, so just be careful with that. A guitar player strikes a string. She then tightens the string and strikes it again. In both cases, she does not put her finger on the frets. How do things change? You are correct if you guess the speed increases and the wavelength increases. Good work. An ocean wave is an example of a blank wave. An ocean wave is an example of a blank wave. You are correct if you guessed transverse. Way to go. And that is the end of this review game. Remember, take a look at your study guide, your notes, the other problem sets. Know your definitions, and good luck tomorrow on your test.